All right, let's get this last example out of the way here. What we have is taking a look at reaction data to figure out our own acid-base strength table. Remember that if a strong acid is above a strong base on these tables, then it is product favored because your reaction is greater than 50%. So we can use the potential reactions and we can use the information about where the position of equilibrium is to make our new table. Let's take a look at the first reaction here. You have an acid, HA. You have a potential base, B minus. You can infer that from the position or the information on the hydrogen that's there, or which would be the better proton acceptor or donator. We can see the conjugate acid base. All right, HA becomes H minus, so this must have been the proton donor. We can also see that the reactants are favored, which means this is the weaker pair. So when we compare our two acids here, HA and HB, we should be able to infer, and I hope you guys can understand, that HB is the stronger of the two acids. So when we start writing down some of our information here, there's our reaction. You have two potential acids, two potential bases. With the reactants being favored, this must be the more aggressive pair pushing the position of equilibrium. So if I had to write where these two would be on a relative strength table, HB should be a superior acid to HA, and there's my conjugate bases. Okay, stronger acid, higher on the table, weaker acid, lower on the table. So we've learned from this first reaction that HB is superior to HA. We did similar things like this when we were looking at OAs and RAs in our reduction tables that we were building back in Electrochem 2. So all we've learned is this. In the next reaction, we should be able to compare to the table and see if we can't figure out if it's going to be above or below our comparison. So we take a look at the next one here, and we have a reaction between acid C and acid D. All right, we have acid C reacting with D minus, acid D reacting with C minus, so you can see our generic acids are HC and HD. This one tells us that the products are favored, so we're getting much more of this hanging out. Okay, great, HC and HD. We can see that HC is the stronger of the two acids. So we go to compare it to our particular table here, and crap. We don't have C or D in this table yet, so I can't figure out where they would be. I may have learned which is stronger between C and D, but I don't know how they compare here. So if you guys remember from our redox chemistry when we were doing this, once we had established something like we have here in red, we had to find a reaction that had a comparison for us. So we'll hold off on C and D. We'll take a look at D and B. B is one that we already know. So here you have HD, here you have HB, you have those two acids. It says that the products are favored, so you've got much more of this hanging out afterwards. This must mean that HD is the stronger of the two. This means that HD is a stronger acid than HB. So there you go, HD and B, you've got your two acids. You can see that the position of equilibrium is to the product side, so there is my strongest of the two acids. Since I already have HB in the table here, I know that HD must be superior to it, and so I've added one new acid and conjugate base to my table. HD is the strongest of the three acids that we've looked at so far. Now I can go back and take a look at that reaction I haven't been able to compare to yet and figure out where HC fits in all of this. So HD is now in the table. I have something to compare to. HC is the one that I'm going to look at and see where it belongs. So between the two acids, C and D, products are favored, which means the forward reaction dominates. HC is the more aggressive proton donor and therefore is stronger than HD according to our position of equilibrium rule. So there we go. There's HC and D. All right, there's your two acids. there's the position of equilibrium, showing that you've got much more of this hanging out afterwards. So that means C is the more aggressive donor, and D is the more aggressive acceptor. And so HC is a stronger acid than HD. And so it would sit above HD in the table. And so there is our list of acids and conjugate bases. And the strongest acid, top left, strongest base, bottom right. Okay, there you go. Try some of that out, put that into practice. The 5-step method is very similar. Instead of looking at OAs and RAs, you are looking at acids and bases and trying to figure out the strongest. The equation is now the proton transfer instead of the electron transfer. So again, really similar ideas there. Take a look at 722 to 731. Try a few to all of those examples. Depends upon how good you want to be at this. Do for sure Lab 16C. That one is available now in Dropbox if you want to submit it. Ignore 16.2. And yeah, good luck with your practice. Hopefully this all works out for you guys. And look for the videos on 16.3 to appear on YouTube shortly. 16.4, obviously, as you guys can see in the news, is being ignored. So we're just about done our acids and bases chapter.